This part is key to the fitting of the intermediate pulley, and so therefore also sets the levels for the spindle and motor pulley. You can see just in there that there's a circlip, and that's basically setting the level for everything. So one of the first things I need to do is work out where is that circlip in relation to the other parts, particularly the spindle pulley, so I can work out how much material I need to take off, and I guess how much material do I need to take off the bottom of the intermediate pulley so that everything else lines up. The plan here is I have the pulley on some parallels. I'm now going to use my height gauge to measure from the parallel surface up to the circlip, and so when I put this back in, I'll know the offset between that top surface and the circlip. Measuring the offsets and things, and then comparing here, I need to take off about 10.5 millimeters, which just happens to be the about that thickness there. So there we go. So basically, if I take this off flush, that should sit in and counterbore for the bearing, that should sit in the same place in terms of belt position as the spindle pulley, and then I can use this to set up where the motor pulley is going to go. I've just faced off that boss, put the counterbore in for the bearing, so that's all good. The soft jaws, the hard jaws on the lathe, I was concerned they might damage the grooves there. So underneath the tape here is a little bit of copper. I find it's easier to tape things under the jaws like this with a bit of masking tape, rather than try and struggle and balance everything and hope they don't fall out and all the rest of it. Here's the drill after we've fitted up the belts. It turns quite nicely, and I'll turn it on in a moment just so you can see that for real. What have I had to do to get here? Well, I've counterbored this pulley so that the original nut can sit down in there, and that's all good. I've got this pulley set up. I need to put a bit of Loctite, low strength stuff though, on the bearing inners. The outers are pushed in quite nicely to the pulley, but that works. I've had to bend this handle out a little bit because the original bend was a bit too close to the pulley for comfort. The motor pulley is fine. You can see the grub screw there. I haven't got a tap that's that deep, and so what I've had to do there is the old standby of drilling a hole, putting a close fitting slug in the tapping drill size in there. So this is a bit of 5mm diameter rod and probably 20-25 millimeters long with a grub screw there. That grub screw doesn't interfere terribly much with the belt going over. It's travelling fast enough that we don't get an interruption there, but it works, and as you can see, quite well. I've put a tacho on this. My lowest speed adjusted for the rated speed of the motor is 150 RPM. My top speed is around about 3,100. Now the original speeds quoted on the guide were something like that, 150 to 3,000 RPM. So I've pretty much got the same speed range, but because of this arrangement, I've got two speeds in the middle which were missing. The original hole was from around about 650 RPM up to 1,300, and I've got something a bit under 800, and I've got 1,030, I think it is, in there. So that just fills that the gap in the range nicely. What's more, and this is the bit that I really like, is that I can slacken this belt off and change that down to that, say, and I don't have to worry about jiggling this around to get the belt tensions right. with the original pulleys there were some speeds where the belts were rather slack and some speeds where the belts were rather tight, whereas this one, it's uniform. If I want to go from my high, or at the moment I'm on the medium range here, but if I want to go to high to low, the same thing applies. I still need to slacken that off and then slacken that off, but once that's back where it is now, this pulley will simply adjust with that, which I think is a great idea. So it's guard time. One of the things I was concerned about was I had to straighten this lever out a little bit to clear the slightly larger pulleys. Or slightly larger sheave. It was getting very close. So I heated that up and bent that out a little bit, but that seems to be okay. It's not fouling there. I can rotate that right round, so that's all good. These two pulleys I wasn't expecting to have a problem with, because they this one in particular is probably shorter than the existing or the previous pulley. This one's a little bit taller, but it's conical. The one that I am concerned about is the front one. And there's a clash, so I have to try doing some stuff about that. I might try putting some spacers in first, I think. Although I can't do much because there's only around about a quarter of an inch, so 6 millimeters worth of clearance between the back there and the motor pulley. As you can see, it's got a slight step to it. Now, the gap you can see down there, I've got the spindle pulley fitted, and I'm holding the guard closed and letting it sit. So that gap measures around about 8 millimeters. So I'd need to find at least 8 millimeters there. As I said, there's only about a quarter of an inch here from the motor to the bottom pulley. So that's not going to work. So I need to, I think, do a bit of cut and shut work on this guard, which I was half expecting to do, but hoping not to. In several of these pulleys, I've had to cut a keyway, and the thought occurred to me, I hadn't actually shown that on camera for anybody who wants to know how that's done. There are various ways you can do it. I mean, you could mark that out and you could file that if you had a lot of patience. I have done it before where I've put a slug of material in there, preferably of the same type, but drilled a hole through there where the key goes, of the right diameter, and then use that as the base for enlarging a slot for a key. If you have a shaper, you can set up a shaper so that the tool goes back and forth and takes that out. I used to have a shaper, but it had a bit too much wear in it to do keyways successfully, so I don't do it that way. What I use are keyway broaches, and that's in this box. So a keyway broach set is basically a selection of what they call bushes, like that, and they go into the bore that you are going to broach, like so, and then you've got broaches, and you push that through using a press of some sort. Please don't be tempted to hammer those. These are brittle, they will break. The bigger ones you might get away with it, but the smaller ones, no, I've been there, done that. Once you do one pass, depending on how deep the key is, you put a shim in and repeat, and so eventually you get to the depth you need. There is a trick to measuring keys. A standard square key is usually pushed in about half the depth. So this is a 6 millimeter broach. So and that's a 19 millimeter hole. So across there, I would expect that to be 19 plus 3 is 22. So I need to make sure that's 22 across there. Okay. So usually I do one pass. I then measure it. I work out what thickness shim I need, and do it again. The books and things recommend using a little bit of grease or oil. For aluminium, I find that I can get away without it, but we may do something along those lines. We'll just see how we go with that. You don't need to have these bushes with heads on them like that. You can use just a bush like that, and that one's actually homemade. I had a bore which I had to run one of these broaches down, and so I just made up a bush. Not difficult to do. You just got to make sure that's supported so it doesn't push out of the press. This is my broaching setup here. Nothing terribly difficult about it. Basically, hydraulic press, hand pump, bit of steel there to hold it. Here I've done my first pass. You can just see a little bit of stuff on the keys, on the teeth there. The trouble with this is it needs about a 12-inch stroke, and this is a 10-inch cylinder, so I need to go back and have another go. I'll put some blocks under there, and so I've measured in there. For my second pass I need something like 1.7 millimeters of shim. The best I'm going to do, I think, is about 1.3, so I'll then have to do another pass to just take that final piece out. Once you've got a groove there, it becomes pretty easy to set up. One of the mistakes I made when doing this project was I used a 3-jaw puller to try and remove the old intermediate pulley, and as you can see I've paid the price for that. Now round there it's flat and round there it's flat, but the piece where it's broken, I don't know whether you can quite see that, but the piece where it's broken has bent. So even if I got that and tried to weld that back in there, which, you know, I guess is possible, it's not. I'm going to have a ding in the pulley. It'll vibrate and all that sort of thing. So I'm going to have to build that up, and the way I do that is with beads of weld, and then I machine it back. So we'll show you that. It's the start of the repair setup. Basically, I'm going to weld that by building up a bead of aluminium. So I've got my pulley clamped in a convenient spot, earth direct to the pulley, because going through thin edges might tend to cause some problems. And then it's just a matter of layering beads up. You want to start with, you know, layering rather than building up in one area and then sort of moving along. The idea, of course, is to put enough material on there that you can then machine back and produce a reasonable groove. So here's the pulley. As you can see, I've just run a whole bunch of beads of TIG across there. I need to build up this face a little bit to give that the correct profile. Inside is not looking too bad. I might have a couple of small problems there where I just started off, but we'll just have to see when we machine. Here's the outside cleaned up. You can see where the... Here's the outside cleaned up. You can see where the weld is or was. There's a slight wetness there. I don't know whether that's because I've distorted the part when I tried getting off with the three-jaw puller, or whether it's just like that. The whole... I've got bushes where the bearings are, and then a tight-fitting mandrel in there, but the whole thing is just shimmying a little bit, so I'm not quite sure what the story is there. However, we'll press on. I'm now going to use a thin parting tool, basically, to get into, or a parting tool to get into there and pick up that angle and clean this bit up. There's the end result. A little bit of clean-up work with a file down the bottom there, because that was a little bit rough. I guess something to remember about V-belts is that they're a friction drive, and they use the sides of the V, so provided that base groove isn't badly distorted, then that should be fine. The important thing is the sides, and I've got a reasonable finish on the sides there, but because, as I said, because it's a friction drive, it should be okay. It'll soon wear the bits that it doesn't like and grab onto the bits that it does. Let's put it that way.
And that's the third video of me modifying my Waldown drill. I need to modify the guard as well, but weather isn't all that good for painting at the moment, so I'll leave that for a little bit. But thanks for watching, please share, and thanks to those who've inspired me.